Well, hello everyone. Thank you for being here. And we're going to spend the next 60 minutes to give you a brief introduction to what CouchDB is and how we can use it as .NET developers. I'm assuming that pretty much everyone here is a .NET developer. So although we will see CouchDB as a whole, a good section of the talk will be focused around how we would use this as a .NET developer. So the agenda today, well, my name is personally Hadi Hariri. I work as a technical evangelist at JetBrains, and I'm also doing some development on some open source stuff. I'm C# MVP, ASP.NET Insider, and my relationship with CouchDB comes more from a frustration that I've been having when developing applications and having to deal with ORMs and mappings and relationships between objects and things like that. And I just thought, why not? Let me try an alternative, see if it works. And it did. So I stuck with it. Why I went with Couch? Well, one of the reasons was the simplicity, which hopefully I'll show you in this webcast. So the agenda today will be an introduction to the concept of document databases and CouchDB. Then we'll see what working with CouchDB is, and then we'll see how to do the same thing using .NET with a couple of different libraries that are in the works and existing today. And then in the last section we'll go through a couple of gotchas that you should be aware about when you're starting to work with document databases. So if we go back to the whole concept of document databases, well, let's take a look first at the history of computing in languages. This is a slide that I put together, which is pretty much all of the computer languages that have existed, or the ones that I managed to get together. And you can see that back from the days of Fortran all the way to today, which I think the latest language is Go, second to first to Clojure. We've had so much progress in terms of different types of languages to create applications. We've had different ways of trying to solve the problems. At the end of the day, most of the problems we are trying to solve are business related. And we've tried to find different ways to make it more expressive, more intuitive, less repeating yourself, nicer, cleaner code, etc. So we've had a whole lot of options. People are constantly thinking of better ways to do things. Now compare that roughly to databases. And we've had the navigational, we've had an attempt at object databases, and then we've had the relational databases. And most of the databases that we talk about today, most of the things we use today, they're mostly relational databases. I mean, every time we start an application, at some point, we always say, right, the database that we're going to use for this is going to be SQL Server, it's going to be Oracle, it's going to be MySQL, it's going to be whatever. I mean, the biggest choice is, should we use this vendor or this vendor? And we've never really thought about, hey, maybe there might be a different way to store information that is not the relational model. We've mostly focused on relational databases. And of course, from a developer's point of view, when we're creating business applications, we've run into what's known as, by many of you probably, as the impedance mismatch, which is how do we map these objects over to tables in a relational model. And we've kind of solved that problem with object relational mappers. Now, the problem is that those object relational mappers have in themselves introduced a series of additional problems, which makes us have to cope with them, be it in terms of mapping from properties to tables, be it in terms of relationships, being in terms of performance, because some mapping should be done in a certain way, others should be done in a different way. But what it boils down to, that at the end of the day, all we've thought about constantly is a relational model. When a customer talks to us and he says to us, I want an invoice, this is what the customer pictures. He pictures a piece of paper with the details, with the invoice header at the top, with the company details on the right, with the total. What we picture what comes immediately to our mind is the relationship model. How do we map this over to this kind of representation in a relational database? And of course, then comes all the different gotchas of what do we deal with if we have no customers associated with an invoice. But customers have to be associated with an invoice. Why? Well, because we have a constraint from the invoice table over to the customer table, and it's a foreign key, and it has to exist. Now, from a business perspective, that's not necessarily always the case. Maybe from a legal perspective, all invoices have to have customers. But from a day-to-day usage, I have myself personally often encountered companies that say, sometimes I don't want to fill in the customer details. I just want to issue an invoice to what they call a customer pass-through custom. And we've said to our clients, well, that's not possible. You need to have some random customer. Normally, we solve that by entering this random 99999 digit for the customer ID, hoping that never again will there be a million customers. So what my point from here is that this relational model that we start to think in actually has started to impose restrictions on the domain that we are trying to deal with. And it's made us actually take concepts of a relational model, an infrastructure concern, over into the business domain. And now our customers know about foreign keys. They know about constraints. They know about tables. Whereas they don't really care about those things. All they care about is the invoice. That's what they care about. Nothing else. They just want to know what an invoice looks like. And they want to store that. So why is that? Well, part of this is that ever since, for those of us that have been to university, for those of us that haven't, every time we have created a new application, we've always been taught that, hey, the way to go about storing data, the most optimum way to store data is using a relational model. So it's been kind of embedded into our brains that every time we start a database application, the first thing we do is create a SQL server or an Oracle server or whatever, and then store our information there. We don't give it much more thought. The only time we go back to it and give it thought is when we run into performance issues. But really, we don't care. We have focused so much on trying to abstract away the underlying storage model that we care more about whether our classes, if we're working with ORMs, have to inherit from a specific type or they don't. And we don't really care about how that specific type is actually stored, persisted to disk. Why? Because we've been taught that the only way to store data is the relational model. But things have changed. Hard drives have become cheaper. Processors have become faster. Memory has become pretty much worthless in terms of price. And of course, things have evolved on how this type of persistence storage mechanism systems are created. New languages have appeared that allow us to create better support for concurrent systems, etc. So although over 30 years we have seen so much improvement over different things, we've never really focused about, hey, maybe it's time to look back at this relational model and see if there's an alternative way to store data that is not between tables and relationships and constraints and foreign keys. So if we think about the relational model, we've always thought about where I have an invoice and I store that onto the database server, I have automatically a table which is an invoice and another table which is invoice details, which is the lines of the invoice. So we have the header and the details. That's always the way we've thought about it. Why? Because we've been taught that. But let's say that we could do something else. Let's say that we could do something as far-fetched and as incredible as it may sound, that instead of taking that invoice and dividing it up into a header and details and storing those, something mind-blowing as just storing the invoice as is. Imagine you take an invoice document and you just store it exactly the way you see it into the database. Now, if I tell my wife or my mother or someone that has no idea about databases that I want to take an invoice, a piece of paper, and I can store that exactly the way it is as a document into this thing called a database, they'll say, yes, that's kind of what I was expecting. Yet if we say that same thing to a developer that has been creating database applications focusing exclusively on the relational model for the past 10 years, he's going to say you're crazy. What do you mean you're going to store the thing exactly the way it is? That's not optimum. It's not possible. It's not viable. You can't do something like that. Where are my constraints? No, 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 no. Don't do things like this. And yet, looking at it from another perspective, it's almost logical to want to store information the way it's represented. Why have we gone to the relational model? Because we've worried about consistency. Because we have worried about storage space. Yet, storage space now is cheap. Consistency is one of those things that has been imposed by us and the limitations that infrastructure has been given to us onto the domain, onto the business. The world in a domain, in a business environment is not immediate. Things don't happen in milliseconds. And yet we want to transport this concept of instantaneous actions over to a database. And this fear of inconsistency has kind of driven us to not look beyond the relational model. Well, we can look beyond. There are other alternatives, and document databases is one of them, and they work. I've tried it. It works for me. It works for a lot of other people. You might have heard of companies like, I'll say Facebook, and someone will say, no, Facebook is not really a business. Facebook is about social media. Yes, I wish my business was as successful as that business that is not about business. They use alternative mechanisms to store data that is not relational. One of those options is what we're here for today, which is CouchDB. And we're going to see how we can actually create applications that are simple, easy to use, using a document database such as CouchDB. So the definition, textbook definition of CouchDB, and I think this was from Wikipedia or from the CouchDB reference guide, is Apache CouchDB is a document-oriented database that can be queried and indexed in a map-reduced fashion using JavaScript. So we'll take a look at exactly what that means as we go through the session today. But right now, let's just focus on what document-oriented is. So when I said that we take an invoice and we store it as such, think of that invoice as a document. If I have a customer with his details and his address and his telephone number, think of all that as a document itself. If I have an order with its lines, that is a document. Document doesn't mean a Word document, although it can, but a document is what is represented in the real world can be stored as that in a database. So CouchDB is a document database that's based on HTTP, and it uses the concept of key-value pairs. So each document is identified by a key. The data, as we'll see, is stored in what's called JSON, which is JavaScript Object Notation. In terms of ACID compliant, ACID is the atomicity and all the features that normal relational databases have. It's ACID compliant in terms of persisting one document. We'll see that it's based on this concept of REST, if you're familiar with REST, which is representational state transfer. So it abides, I always say in quotes, it's a RESTful architecture, because it abides by most of the constraints that REST imposes. And it was initially written in C++, but currently it's written in Erlang, which is a great language for concurrent systems. How much do I know about Erlang? Absolutely nothing. So don't ask me anything about that. What are the main characteristics of CouchDB? Well, first of all, it's based on the concept of multi-version concurrency control. What that pretty much means is that every time I write a document, when I write a document, it writes it to the database. When I update that document, what it does, it will not go and fetch that document and update the fields, but it will create an absolutely complete new version of that document. It doesn't have to do any seeks. It also means that it has multiple versions of the same document. So if I have an invoice and then I update that invoice to add an item, I will have two versions of that invoice. Now, from a developer's perspective or from a user's perspective, we will only work with one version. The other versions we'll see that can be compacted and eliminated from the database. Again, storage is cheap, it's not a problem. This, of course, allows for high concurrency because you don't have to lock anything to update. It allows for easy replication, which we can talk about a little bit later on. It comes in multiple platforms. That's one of the key features, again, of Couch. You can run it on Windows, on Linux, on Android. I have CouchDB running on my Android phone, and I have to tell you, I love it. The fact that you can take your phone and hit Start CouchDB and have a full database server sitting on your Android phone that you can work offline is great. It's fascinating. I'm still mind blown every time I see it myself. And I'm not sure right now if it's working on iPhone, but I'm pretty certain that if not, it will eventually. So what is this Couch JSON thing that I mentioned before? So CouchDB uses JSON to store the information. This is JSON. It's a way to represent JavaScript. It's a way to represent terms of characters required. This goes back to the days of AJAX. If you're familiar with AJAX, which stands for Asynchronous JavaScript and XML, originally the libraries were about making calls to a server and getting back XML. Problem is that XML is too verbose. If I want to send 2 bytes, I've got to send 300 other bytes to represent greater than, lower than signals and symbols and all the junk that evolves around XML that's not needed. So a lot of libraries started to use JSON, which is a more compact way of representing objects. So what you see on screen right now is a JavaScript object which has a property called name, a surname, an email, salary, a field active, and then it has a property called phones, which consists in itself of an array of strings. That is an object. This is an object. Again, name, surname, email, salary. Instead of phones being an array of string in this case, phones in itself is another object which has a property home and a property work. So in terms of CouchDB, the document is stored using this format. Now, a lot of people say, well, or it's actually said that CouchDB is schemaless. Yes, it's schemaless in the sense that if we think about a traditional database where we have a table which has a name, and then inside that table we have columns which have a name, a type, and a size. Here we don't have that. Here we can store in our database anything we want. So there is no schema, there is no requirements that have to be met, apart from one minor one, which we'll see in a second. But overall, you can store anything you want. But it does have schema in the sense that JSON itself is a great way to represent information. Because if you look at this document, you can see exactly what a customer looks like. It has a name, it has a surname, it has an email, it has a salary. So there is schema in there. But you're not constrained to having to store that information each time. So just the same way that this is a customer, if tomorrow I have another customer that doesn't have phones, I don't have to store the phones. Couch will not say to me, you have a document which requires a field phones to be stored. I can store a customer without phones. What does this give us? Well, in terms of having to do migrations, from the database side at least of that, we get rid of it. We no longer have the issue of I just inserted a new customer that has a phone field, but that phone field doesn't exist in the underlying database structure. It doesn't have to. We can store whatever we want. which is great. It offers great flexibility in terms of not having to deal with migrations. Now, I said that there are no constraints. There are two minor ones. Each document has an ID and the revision. The ID is what identifies the document. Remember that I said Couch stores keys documents, so the key is the ID. And the revision is the multiple revisions of that document. So each time a document is written, a new revision number is assigned. And we'll see how we work with those revisions in a moment. Now, this talk is CouchDB for .NET developers. And I could have completely skipped this section and said, right, this is how we work with CouchDB from .NET. But I won't, because if you see the API of Couch and realize how simple it is, then you'll see that actually working with it is simple no matter what language you use. Because one of the advantages, as I mentioned, of CouchDB is that you can run it on multiple platforms. So I can run it on Android. I have a full built-in server on Android. How do I access Couch on Android? Well, this is pretty much the same way I would do it on .NET. One is Java, one is .NET. And when we'll see the API, we'll see why that is so easy, so beautiful to do. So it's based on a RESTful API, and RESTful, it comes from representational state transfer, which means let's embrace kind of the constraints by which the web was built on, which is let's make use of HTTP verbs, the get, the put, the post, the head, the delete. Let's make use of status codes. When we retrieve a document that's existed, we get a 200. When we create a document, we should get a 201. When we try to access something that's not allowed, we get a 403. So we have to, we can embrace these status codes. Now, a lot of times when I see applications embracing status codes is they embrace the 200 and the 500. So if everything's good, I'll issue 200. If something's wrong, I'll just say internal server at 500. No, there's much more than that in terms of statuses with HTTP. So CouchDB utilizes this in terms of embracing HTTP as a protocol. As such, that means that everything for Couch is run using HTTP. So I can use any client that talks HTTP to talk to Couch. Here's one. This is curl, which is a command line URL. Here's another I'm sure you're familiar with, FIDDLER, which is a proxy intercept it's an intercept traffic intercept what the requests are going by for each petition you make from your browser or from your, which is called Request Builder, which allows you to input specific requests and make a request to a server. I can use a browser via FUTON. What is FUTON? FUTON is the actual web interface that comes inside CouchDB. So when I when I install CouchDB, by default, on port by default 5_utils. You go to that site, you have your FUTON, which is the web interface for CouchDB. From there, you can create documents, you can create views, you can create modify permissions, you can do pretty much everything. So it's kind of, in the terms of the .NET world, it would be the equivalent to SQL Management Studio. Now, we're not going to use FUTON. Actually, because of the lag, etc., it was recommended that I don't do desktop sharing, etc. So I've had to kind of put all the things that I'm going to show you inside the slides so that we don't have to constantly be switching. However, pretty much all the examples that you see here I have available in code with examples, with applications using ASP.NET MVC, using class libraries, etc. So feel free to ping me afterwards and I will send you the code. So let's start with Couch. Let's start with creating a database. So I'm using curl, which is just pretty much passing in requests to Couch via the command line. Now to execute Couch, if you download it for Windows, there's an installer, or you can download the source and compile, and it installs in a folder, and you can either run it as a Windows service, or you can execute it using a batch file, which is called couchdb.bat. In this case, what I do is I normally run CouchDB.bat in development because it gives me a nice log output of all the requests being made. So once you have that running, from there on, to talk to Couch is just making requests to it, HTTP requests. So to create a database, I just type curl. The -x in curl represents the verb, so I can override it. By default, curl is always a get. I can override that by putting -x and then the verb. I want to create a database. So in terms of REST, that would be equivalent to a put or a post, but with post you would have to get the ID generated by the server. Sorry, pass in the ID, whereas with put, the server would generate it. So in this case, I want to put a database. I want to create a database, so I just say curl-x put localhost 5984, which is the default of where Couch is installed, Webcast. That's the name of the database. If everything goes good, I get a OK true. That's just a JSON saying that the result was OK. Something's wrong, I'll get the appropriate status code and the message. If I want to delete a database, I just put curl-x delete and the name of the database. That's simple. That is the equivalent of creating a database in SQL Server Management Studio or deleting or dropping a database. If I want to list all databases, I will just do localhost 5984 underscore all underscore DBSs, and that will give me an array of all the databases that are running on that server. It's that simple. What about working with documents? Because up to now, what we've done is create a database. So with Couch, the first thing you do is create a database. From this point on, now you can start to create documents. And you can put any type of document in that database. So there's no table. If you want to create a customer, it's just a document that represents your customer. If you want to create an invoice, it's just a document that represents an invoice. You don't have to create tables. There's no such concept as tables inside databases. One recommended approach always is to have a field in your document that says what type of document it is, so that your application knows what it's dealing with. To create a document, what I do is I write curl-x put the name of the database, which would be customers, and then the ID. I want to generate the ID, so this wouldn't be the equivalent of the auto increment. This would be me generating the ID for that, the key for that record. So I say I want to create a document with the key Joe, and then -d, and I pass in the actual data for that document, which is surname Smith, email joe@gmail.com. When I run that, Couch replies with OK true, the ID, and then the revision. This means that it's created the ID and I've got the first revision number. This number is generated internally by Couch, and this is telling me what number of the document it is. What is the revision number? In this case, the first one. That's simple. With that, I now have a document in my database which is Joe with a surname field and an email. Retrieving a document is even easier. I retrieve documents by key. So here it's -Joe, and that will give me back my document with the surname, with the email, and the revision number, again as a JSON document. Updating. I pass in Joe with a put, the revision number that I want to update. Now this is important because when you fetch a document, from the time you fetch it to the time you update it, what might happen is that someone else has updated that document. So what Couch does ask you to do is tell it which revision of the document you want updated. What this means that normally when you're working in this way with Couch, you would have to get the document, make sure that there aren't any conflicts, and then submit it to the server. If you don't pass in the revision number, then Couch would tell you that there is an actual conflict that's occurred. If I send this request to the server, I would get back, again, OK true if everything goes well, and now you'll see that the revision number is incremented. So this is the second revision of my document. Okay, where are we? I have lost updating documents. Correct. Deleting. Again, simple. X delete and the name of the ID of the document we want to delete and the revision number. Again, similar to update, we have to pass in the revision number. So you can see that pretty much the API of Couch is the 4 or 5 words of HTTP. That's it. And there's nothing else. Get to get, post, put to update, to create, delete. Not much more to it. It's that simple. So if you look at the get, where we wanted to retrieve a document, what we've done right now is just get a document by the ID. So what happens in this case? Let's say that in normal applications I have queries. I want to do this. Select email, comma, phone from customer where email equals joe@gmail. What do I do there? Because right now, if we go back to the slide where we are retrieving a document, we see that we're passing in the ID and we're getting back the whole customer. What happens when I want this layout? Where first of all, I don't want the whole customer record. I just want the email and the phone. And then I don't want to query it by the ID. I want to query it by email. This is a must. I mean, this is the minimum functionality that I looked for when I was looking at alternative ways to store data, because I do these things in my application. How would I solve that problem? Well, that's where the map reduce thing comes in that we mentioned at the beginning of the talk. So if we look at what map does, basically, let's say that this is the document that I have stored in my Couch database. And what I want to do is take this document and I want to just get the email and the phone. What I can do is a map operation, and what this does is project one representation of the document to a different one. So I am mapping this document to a different representation, where I will now only get my email and my phone. We'll see how we do this in a second. Once I have that, now I have a different version of that document that only has the 2 fields that I'm interested in. So the next step is, so right now we have this. The next step is getting the where email equals joe@gmail.com. I'm moving my mouse and underlining fields, and just hit me that maybe you guys are not seeing me moving my mouse and underlining fields. Anyway, sorry about that. So what we need to do now is we have the email dash phone. What we need to get is where email equals joe@gmail. How do we do that? Well, when we do this mapping, the first field of that mapping that we've done is now converted into what would be the equivalent of the key. So now we can run queries against this first field. So we get the key as email, and we can run these queries. So when I run this query, which is like this, I write databases design search view by email, I will get the data. I'll show you how that's done in a second. Sorry, wrong slide. So what I'm doing now is I'm querying it by the first field of the resulting of that mapping. Okay. Now we can just run queries on the URL and type in the value of the key we want to query by. Before we see that though, one important notion is that the resulting of these queries are going to be grouped by key. So if I want to have the key as country, then all of the customers that are of Norway would be grouped, and we'll see why that's useful in a second. So these mappings are created using JavaScript, although you can use other types of languages, like I think they were mentioned that you can use, for example, PHP, etc. if you want inside the mappings, although I've always limited it to JavaScript. And what they are done is, all we're doing really is just creating a document, and it's called a view document. So basically this mapping is created and it's stored as another document, as a special document inside CouchDB, which is called a design document and a view. And what happens is that the first time someone queries this new view, it will calculate the mapping and store the results. So the subsequent calls to this view are much more performant. They're not, it's not recalculating it each time, because take into account that if I have a whole bunch of data and I have to map it to a different representation, that can get costly. That's only done once. And then what happens is that when a record is updated, CouchDB will know how to recalculate the views to have the correct information in place. This is how you create those views. All it is just another document. But in this case, the ID has a special name, which is _design, and then the name of what's called the view, the design document. And then it has a revision number, the language it's using, and then inside here we have all the different views. So I have a views by email, and I say, this is JavaScript. I take in the input, which is the document, and I say emit doc email doc name. Basically what I'm saying here is that take the document and emit these two values, the email and the name. Those are the properties I'm interested in. If I want to do the same by surname, I will do exactly the same. What is the difference between these two? It's the first field that is being emitted. So whereas here by email, I'm identifying that I can now do searches by email, and with this view I can do searches by surname. Okay? How do we actually use this? If we come down here, we can now call _design search _view. This is standard. _design is standard. Search is the name we just gave the design document. _view again is standard, and then the view name by email. And I will get all of the views, sorry, all of the documents mapped according to how I have my map function. And this is where the next step comes in. We now have select email, phone. We now want to restrict that to where email equals joe@gmail.com. And that's where the filtering is. So I say by email and then pass in key equals mail@hadihariri.com. What will happen there is that it will only return those keys that match the one I've put in. We can go one step further and even do a range of keys. So we can do from start key to end key. So with this, the basics of queries we already have done. Okay. Now from a .NET perspective, and when we talk a little bit about LINQ, we'll see that where this might have an impact on the way we design applications. What's the next step? Well, those are normal queries that we do. Select fields from some table where some condition is met. Okay. Now, what about when we want to do things like aggregation? What about when we want to do things like sum? Now remember that I said that the results are grouped by the key. So that's where the reduce function comes in. And what reduce does is take a series of documents and reduce them to produce one result. So in this case, what I'm doing is I'm doing a count. So I will just reduce all of the documents, which is basically count them and return a result. There are some built-in functions like sum, count, etc. And just similar to the views, the mapping, the reduce is done in the same way. This is the exact same design document we had previously, but whereas previously we only had a map function, here we also have a reduce function. The built-in reduce functions, as I said, are sum and count, and you can do a whole bunch of complex operations with reduce. And yes, initially when you start to work with CouchDB, there are some situations where you're not sure how you would do certain reductions with your data, but luckily in the CouchDB definitive guide, there's a whole section on what is called the SQL CouchDB for SQL jockeys, where it tells you a whole bunch of best practices and how to do certain things that you're accustomed to in the SQL relational model. Okay. So basically, coming back to the API, we have the different operations to create, to delete, to get documents. When we want to do queries, we then create maps to represent the way, the fields we want to obtain from that queries, and then we can use the keys to reduce the result set that we get back. That is the API. That's all there is to Couch. So what happens when we want to use Couch from .NET? Well, there's multiple ways. If the API is that simple, we could really just use an HTTP client and a JavaScript serializer, which just takes objects and it serializes them into JSON, gets JSON and deserializes them into objects. Or we could use libraries. Now there's a bunch of libraries that we'll quickly review here. There's OTTOMAN, CouchDB.NET, which is a new one which I just found the other day. Divan and Sharp Couch. Pure HTTP. This is a small library that I wrote, which is called EASYHTTP, which is on GitHub. It's available, and it uses the dynamic type in .NET, which works great when you're working with JSON. And basically what it is, it's a wrapper around the web request in .NET. So when I want to get a customer with just issuing HTTP in C# code, I just write bar HTTP new HTTP client, then do a get on the customer, and then I can say customer dynamic equals response dot dynamic body. And what this gives me back is a dynamic object in C#. And now I can just do customer dynamic dot first name, customer dynamic dot last name, customer dynamic dot email. If you're not happy working with dynamic types and you want to work with static types, you can just do response static body, pass in the type that you want it deserialized to, in this case customer, and then you can just have a strongly typed customer class. That's all there is to it, to working with Couch from .NET just using pure HTTP. If you want to create a customer, again, very simple. I just do var customer equals new customer, pass in the field's name, and in this case we do a post. I'm passing in 127.0.0.1.5.9.8.4, the database, the object, and application JSON, which is telling this method post to serialize this object into a JSON format. That's all there is to it. Now, if you're not happy working with HTTP, then you can create simple wrappers. This is just a wrapper I found from CouchDB.NET, which takes the concept of HTTP client and just wraps it in a sample repository where you can just now work with strongly typed classes and do gets and saves, etc. The next library, which is in the works now, and Dale Reagan is the author, and he's working hard on it. It's actually I think it's a rewrite or a second version. There was already an initial one, but he's doing it from scratch in a much better way, is OTTOMAN. And that's a more native API. So if you're accustomed to working with NHibernate or Entity Framework, where you have methods of such as save or load, etc., this will fit right in. Now it is work in progress, but it's going in a very nice direction. And when we look at LINQ, I'll mention something about that also. And it's you can obtain it from github.com/signsignal/OTTOMAN. I'll show you what the code looks like if you're working with OTTOMAN. So working with a database, you have the object, which is a Couch client, and then you just say, I want to connect to the IP of my server, and we can just create a database by calling couchclient.createDatabase. We can get a database by calling couchclient.getDatabase. We can delete a database by using delete database. So you can see that what it's doing is abstracting all the HTTP away. You don't have to worry about anything like that. And it does pretty much the same when it comes to working with documents. So here we have a Couch document session, and we take the previous Couch database that we had obtained and say open document session. Then we take an entity. This can be a customer, it can be whatever we want. We set the properties, and then we say customer Couch document session dot store the entity, and then Couch document session dot save changes. Now again, as I said, if you're familiar with NHibernate or Entity ORM, you'll know of the unit of work pattern where you can take multiple changes and then persist them. This is kind of trying to follow that pattern where you just take your entities, create whatever you want, and then just store them, and then when you hit save changes, that's the time it's going to persist it to the database. To do loading of the entity and modifying it, again, it's very familiar syntax to what you're accustomed to working with other ORM, so you do couch document session dot load entity, pass in the ID, and then just modify whatever you want and save changes. So you see, back when we were working with the API, or if you want to work with CouchDB using a wrapper, be it EasyHTTP or the default web request, you would have to worry about getting the revision number, obtaining that revision number, posting that revision number, etc. Whereas if you're using something like OTTOMAN, you don't have to worry about that. It's all done for you under the covers, which is great. I mean, in terms of productivity, it's much better than having to deal with all this manually. Of course, you could also abstract this yourself, but again, that's a kind of like, why reinvent the wheel if it's already being created. A couple of gotchas. You see that working with Couch itself is not that hard. The first question is, what about LINQ? Right? We love LINQ. We're .NET developers and we love LINQ. Now, Divan is another library that exists, and that has initial support for LINQ, so you can write your queries using LINQ. However, you have to restrict it to views that exist that match those queries. So you can't do dynamic queries. You can't generate queries on the fly. There is an option to do dynamic queries. The thing is that it uses what's called temp views in CouchDB, which is not a good idea, because basically the concept of temp views is that I generate a view, which is a mapping, and then I run the view and it's dumped. It's not saved. Now, for testing purposes or using it via FUTON, that's great. But in production, you don't want to do that, because one of the benefits of the speed of CouchDB is that it persists those views so that the next hit doesn't have a performance penalty. If every time you hit that view it's going to recreate it, you're going to run into an issue. Okay. Now, having said that, we're working with Dale Reagan from OTTOMAN, and myself, hopefully, we're thinking about some things in terms of LINQ, so that you would be able to obtain kind of dynamic links using CouchDB and do your dynamic queries without having to mess with creating map functions or actually touching JavaScript. That's something that him and I have been discussing, and I think he started working on it, which will, open up the door to a lot of people that are not really happy of touching JavaScript or working with JavaScript. Okay. In terms of joins, where are my joins? Right? I said that you take a document such as an invoice and you persist this at such. What about the details? Well, if you persist an invoice with the header and the details, it will be in one document. However, sometimes that's not necessarily what you want, because remember that each time you get a document, you will have to get the document and update it, although there is the concept of a kind of like partial update, but that's more for an advanced CouchDB talk, which I think are already on the website. But there are times where you want to persist the information differently. Sometimes you do want to actually have a kind of relationship between two documents inside your database. Sometimes you do want to have a blog and then stored in one document, and then the comments stored individually in other documents. And you can kind of map these two by using IDs. So it's based on the usage scenario is where you could do it either as an embedded document or mapped related between IDs. Again, this depends on your usage scenario of how you're going to talk to the data. When it comes to transactions, there is not really support for sending multiple transactions to multiple documents to Couch in one transaction as such. There is a concept of a bulk update, but it does have issues with replication. So when you're playing with transactions, you can't really think of, okay, I'll send create an operation that updates two documents. What happens if one of them fails? Those aren't going to be wrapped in the transactions. However, that is something that you can also focus differently. Again, if you go to the CouchDB definitive guide, it walks you through the scenario, for example, of a transfer between two accounts, how to update the balances of both accounts inside a single transaction, it's a very good read because it shows you how you can think differently about how you play with transactions, getting the benefit that you actually gain more by focusing transactions differently. So in the sense of the account transfer, instead of updating two accounts, what we would actually do is persist the actual transaction that takes place. So we not only have the balance in the two accounts, but we have the intention, the operation that took place. So again, it's a little bit different. You have to think a little bit differently about how you're working with transactions when you're working with Couch. So to sum up, Couch is much more than what you've seen here. I mean, as I said, there's a lot of webcasts on O'Reilly where you can go and look into replication and changes in continuous feeds and things like that. This is just an introduction. But replication is great. It's very easy to replicate. Basically, replication is, again, issuing a request to the server with the origin and the destination server. You can subscribe to changes feed, which alerts you every time there's a change so that you want to do a new replication when there is a change. It has support for validation. So one thing that a lot of people are afraid of is what happens when I want to persist some information and I want it to abide with some constraints. You can actually do that with the validate doc update. Security, it has built-in support for cookies, OAuth, HTTP, etc. And finally, and one of the most important things, CouchDB is much more than a database. It's actually an application. So working with this, like for example with ASP.NET MVC, if one day you don't want ASP.NET MVC, you don't even have to use it. You can create your views, you can create your listings, you can create everything with Couch app using jQuery. So you don't actually need a third tier. It's just one tier that sits on your server which serves the data and serves the applications. So it's much more than what we've seen here. Okay? Ideal for, again, I used it because I was tired of mapping. And for scenarios where you're doing domain-driven design, if you're thinking in terms of a customer and all the relationships it has, that's a good scenario. For scenarios where you need easy replication or offline support, again, it's very good because it works on multiple platforms. And again, one of the things that attracted me most to CouchDB was its simplicity. So more than what we've seen here, but unfortunately there's not a lot of time to get into great detail about it. But hopefully with what you've seen so far, it kind of gives you a feel of what CouchDB is about and how you can play with it from .NET. So with that, I am done. Catherine, I think we could have a few questions. I know we're running a little bit over time, but if you think it's okay, 5 minutes to have questions?
Oh, certainly. I certainly do. We have quite a number of questions over here, and I was reading a lengthy one that just came in by James. But perhaps you could start, look through these on the side. I see that there's a question, what in terms of performance do you lose by using HTTP instead of TCP, such as in MongoDB? I don't know if you want to answer that one.
Okay, I have not worked.
I'm sorry,
Mongo,
I just,
so I wouldn't ever be able to do any type of comparison in terms of performance with Mongo. So all you're doing is adding an application protocol on top of TCP. So the communication is the same. What you're doing is just embracing HTTP, embracing its status codes, embracing its verbs, so you don't have to create a new API. You're just using HTTP itself. That's the only difference, really.
Okay. All right.
Next question, Catherine. Are you going to read these, or shall I read these?
I'd be happy to read them.
There's a couple of long ones here. Okay, James. Okay, great. Yeah. Go ahead.
I think actually we're having a little bit of latency, and I told you that often happens when when we're talking across the ocean. Maybe you should read them yourself.
Yeah.
Okay.
Okay, so the next question is James, pick up question. I'm planning to use CouchDB for a system containing huge volumes of statistical data for a large subscriber base. This will involve mostly updates and writes to the database. How would you approach dividing the data by subscriber, e.g. by document or value pair? The dilemma being that the subscriber can be as large as individual subscriber. Okay, I think this is quite a bit of a long question. I would have to think about this. So let me go over with the smaller questions first, and then if we have time, we'll get back to this. And if not, we can take it offline. In the name value, it's a question from Stephen Russell. In the name value pairs, can I query data there? I need to find the user who keeps updating the document. You can get information about the user. There is a user context field, so you can access the user information about who is accessing the document. So you should be able to. Another question is, I have customer interacting with partner. They are making a doc and kicking to one another often. I need to track if partner is what they entered, and that is why it's kicked back to them. I don't know if this is part of the same question or... okay, Stephen Russell, second question. If you can either clear it up or contact me offline, because I'm not following that one. Nitin question, can you elaborate more on views and how updates are handled? I read that the view is recreated on first view. Yeah, the first time you create a view, so the first time you hit the view, you query it, it will be created. After that, then it will only update the nodes that need to be updated. So there is more information about the actual query in the definitive guide. So you can see how the queries are persisted and how it's basically using a B+ tree to persist the information. Thomas Johnson said, question, is that view persisted between server restarts? Yes. As far as I know, yes. Then we go back to the meeting. Yeah, I think they're... Catherine, I don't know if the questions are coming back repeat, so I'm not sure if I've got all of them.
Oh, some of them, I'm afraid, were pasted in there twice. Okay. There's one by William here with the multiple revision approach. How do I make sure I always get the latest version by get query?
Okay, so basically when you want to... First of all, you shouldn't rely on the versions at all. So that's not something that you would use for logging. If you want to do logging or keep history of revisions, don't use the multiple revisions that Couch gives you. Because when you compact the database, that's gone. What you would do is when you want to write, you would have to get the latest version. So you would have to do a get. When you do a get, you don't have to pass in the revision number because it will always give you the latest one it has. So you will get the latest one. From there, you would then access the revision numbers, and when you post, you would then post that information with that revision number.
And we have another question. Is it possible to set up unique indexes?
I'm not sure if that's...
Yes. There are a couple new questions there, Hadi. I'm afraid we have a bit of latency here. So... Can you hear me?
Hello?
I think we should probably wrap it up.
Hello? Hi. Oh, yeah. Okay. I can hear you now. Yeah. Sorry.
Okay.
We're going to wrap it up?
Yes, I think so.
No, sorry. I just heard wrap it up. I can see one question. Is it possible to set up unique indexes? Each document is uniquely identified. If you want to set up a unique index, no, you would have to. The only way, I mean, if you're talking about if I persist an information, like for example, email, I want to make sure that there's no two emails the same. You can do that. You would have to do it by the key pretty much. I'm not sure about Catherine.
I think we should probably wrap it up. I think you've answered all the questions, Hadi, and you've done a fabulous job. So we should probably...
the details, my Twitter account is there, my email is there. If there are, because it's kind of hard with the latency with the questions. If there is any that have not been answered or they have further questions, please feel free to email me, and I will do my very best to help you if I can. And if not, I'll direct you to some resources where you could find more information.
Great, thank you. And I just want to say again, I don't know if you can hear me, Hadi, but that was a wonderful webcast. I'm so impressed by how much you covered and how simple you made it seem, and I know it's probably not at all. But thank you, everyone, and thank you, Hadi, for doing this. And I hope that you'll join us in the new year. This is our last webcast of the year, in the new year for the ongoing saga of CouchDB webcast. So we'll look forward to having you all back. And thank you so much, Anna and J. Chris and Hadi and everyone. So we'll see you again next time.
Yep.
All right.
Bye-bye.
Goodbye.